What? Who's forgetting minuses? Hi, Mr. Krowski. Wow. Yeah.
Trig identity.
Hot stuff today.
This is just way out of my league. You get a second for me?
Yeah, I do. So it's cosecant x minus cotangent x?
Yeah.
Oh.
That's why you multiply.
What is it, the next lesson?
Let me take over.
No, it's 5.
Go ahead, John.
Hey.
Like part 5 let me do that. Oh, hold on.
All right, class, pay attention.
Class.
Yeah, I'll show it in a second, okay? All right, Kelly, you got it? Okay, so what do we want to do first, class?
I want to turn the cosecant into 1
In the denominator?
Wait, actually, no, I want to multiply by the root.
There you go.
Denominator. You got to multiply by cosecant x plus cotangent.
Bun with another.
That's right.
Oh, I gotta make the buckets?
That's our bun identity.
What? It hit the rim!
I can't touch it up.
That's all they can.
He's got the bun, he's got the track jacket.
Religious.
He's got the official Tufts uniform.
You always do political economics.
All right, class, now what? When we're multiplying this, what do we get on both
Ooh, that
sides?
is an interesting approach. Okay.
So you're going to get sine x cosecant x plus cotangent x sine x on the numerator.
Let's take this off of another certificate, actually. Did he show you magic?
So,
And then the denominator is different to 2 squares, so it's going to be like squared first term, squared second term.
With what sign in between?
Minus.
all right, we're doing good. Do you guys understand my handwriting?
Yes, sir.
All right, good.
Yes, Mr. Picnic.
All right, can you guys see that over there? Okay, so now what do you guys want to do?
Can you use green, actually?
All right, I'll switch to green just for you guys. Now what?
Shout out to G-Show.
Change cosecant squared x to cot squared x plus 1.
To what squared x plus 1?
Cot,
Oh, cot squared x plus 1? So you want cotangent squared x plus 1 minus cotangent squared x?
Yeah.
All right, I see you. You know, I think I'm just going to erase that. So I don't have to rewrite it.
Oh, wow.
All right. I think that should be correct, right? So
So
what
it
do you wanna
was
do with that?
cosecant squared x. And Jordan said to change cosecant squared x into cotangent squared x plus 1.
See, now, what I'm thinking now is to, since we have this denominator, I want to split up this numerator. What are you guys thinking?
No.
What do you want to do?
Oh, and you cancel out the cotangent. We have a denominator.
There you go. There you go.
Oh, yeah.
So now we just have a positive 1 in the denominator. So we pretty much don't have a denominator.
Yeah.
Which is neat. So now we just have sine x times cosecant x plus. All right. So
So now tan x equals 1 over sine x. So that will cancel
there you
out
go.
the
Now you're
sine.
thinking. Now you're thinking.
No, don't erase it. You gotta rewrite it.
Gotta rewrite the whole thing.
Come on, Mr. Picnic.
All right, all right. Oh man, that wasn't even this.
What's the relationship between sine and cosecant?
They're reciprocals.
They're reciprocals. When you multiply the reciprocals, you get...
Woo! I'm just gonna do the reciprocal for cotangent, which is cosine over sine,
Sounds good to me.
and that will also cancel out.
Mazda likes it.
Okay. So now, you have this cancels out here, and this cancels out here, so you just have 1. 1.
Oh.
And then, since this is a fraction, it's just over 1, this would cancel out here, and this would cancel out here.
So we
You
can.
guys see that over here? So then you would just have cosine plus cosine x. Oh man.
Yeah.
Wait.
Go now.
You can't simplify that further.
I don't think so. Unless you want like 1 over secant or something.
I don't.
Okay, good.
Yeah.
Nicely done, John. Mr. Picnic? Yes.
It's hard to show me.
You have a challenge? Yeah, you guys applauded for him too, so.
There's another track suit in town.
I don't have a full suit.
Oh no.
My driving teacher used to like wear full track suits. It's really funny.
Where are we at here?
Show the talent.
Hold on.
We're on this guy?
Hold on.
Is that 42?
Whoa.
That's 42.
No. You took this out.
310x over 1 minus cosine x.
Okay.
What? Do it last, but it's 42.
Problems over on the board. Look a little scar.
Wait, where's 42?
Right here.
Where?
310x 1 minus
Oh,
cosine
it's so
x.
tiny.
And this is in the get rid of the denominator section, right?
Yeah.
Oh boy. Do we have an identity for 1 over 1 minus cosine x? No.
Squared.
If it's squared, can we make it squared?
See? With the tangent, you can change the sine over cosine.
I do. Right now? Okay.
I reckon we multiply that reciprocal.
Multiply by
Reciprocal of the denominator.
reciprocal of the denominator. Mr. P says multiply by 1 plus cosine x over 1 plus cosine x. Yeah. And when we do that, what do we get? Let's draw a little line. We have 3 tan x because we multiplied 3 tan x times 1.
Yes.
And now we have plus 3 tan x cosine x all over.
Yeah. 1 squared minus cosine squared x.
There you
1
go.
minus cosine squared x. Pilan is on a roll today.
Yeah.
We did not get rid of the denominator yet. But what's 1 minus cosine squared x?
Sine squared.
It's sine squared x. So new denominator is now sine squared x. What's our new numerator?
Hold on. You can add the. No.
We have tan times cosine.
You can cancel
Or
out.
you could take
Like
it back
3
to.
sine x
Oh.
on the last
Yes.
All right, yes, you could factor, but if we factored, we're going to be back to where we were initially.
That's true. Sine over,
What's tan?
sine over cosine.
No, it's a color.
Oh.
Oh,
Trig opens the door for a lot of terrible jokes.
Terrible drugs?
Jokes.
Oh.
More cokes.
this is recorded. You can't say
Into the
wrong.
drug.
That's right, don't say drugs.
Don't do drugs either.
there.
I'm sorry.
Tangent
my
is sine over
like
cosine, and we're multiplying by cosine, so what happens?
Cancel out.
We get some reduction. We have 3 tangent x plus 3 sine x, and it's back, over sine squared x.
Hey, Meta. What the heck? That Meta.
Was that you or was that that?
No, you're not in the way.
You weren't in it.
That's not the problem.
I don't know. What do you got?
Tennis never
I
Meta.
don't know.
That's I think.
What did you do?
You're so alone.
All right.
Just take the front chair.
You know what? I'm tired of writing this 3 over and over for every term.
Oh.
Okay.
Oh.
All right, so let's write this as 3 parentheses.
Oh.
10x.
That's good.
I know, isn't it? So like
Dreading going home. I'm dreading going home.
All right.
I'm really done.
Get a sin x squared.
for 10, I was up till
Not yet.
I woke up at 5.
Wait,
Jordan says it cancels out the sign. Now, all right, you could make a case for it, but let's make this look mathematically nicer.
Oh, well, just like randomly guess for every single thing you could expect and just
Can't you do like 3 sine x over cosine x over sine squared 2x plus sine x over sine squared 2x?
You absolutely can. Yep.
Okay.
So again, as suggested, splitting this, you have a sum in your numerator. You have just the term in your denominator. You are welcome to split this into 2 fractions. Absolutely fine. What do you have over here? You have sine over cosine, and here you have sine. So what do you have in both terms? In both sine over cosine and sine?
Sine.
You have sine. Did you see the sign? It's right here. Oh, another one. So if you factor that out,
Here's your sign.
I was not waiting for that one. I'm going to have that song in my head all day today, and I have only myself to blame.
You know that one hillbilly comedian who says, "Here's your sign" all the time? Guy's name.
No.
You know? Oh, you never saw him? He's like with Larry the Cable Guy. And every time he says something, then he says, "Here's your sign."
I don't know.
You gotta look it up now.
Now we can go back to what Jordan said, is that we can cancel out one of the signs. We have sine as a multiplier in the numerator, and one of them in the denominator.
Denominator.
So we can say 3 times 1 over cosine x plus 1,
Okay.
all over sine of x.
Oh my goodness. Wait a minute. So you're allowed to do that if you just combine the cosine and plus 1 with parentheses?
You're allowed to do that if what?
You see how you said you can't do that unless you have all multiplication in the numerator?
Yes.
So pretty much you just covered it with parentheses, and now you would have to distribute the 3 if you were to separate them again?
Yeah, we do have multiplication in the numerator. Yes, inside here, this is a sum. But we have 3 times sine of x times this entire quantity. So it is all multiplication up there, even though one of those terms does have addition in it. So where are we at? We're at 3 times that quantity, 1 over cosine plus 1, times sine of x. Multiply by 1 over sine of x.
No, multiply by
Does 1 over cosine have another identity?
cosecant?
Yeah.
No, wait. Are you talking about the sign in the denominator or the cosine?
The cosine.
Oh, might be.
So we could change 1 over cosine x to secant x. Just so we don't have like a fraction and a fraction. No, it doesn't help us reduce anything. No, it's not that enticing, but we don't have this anymore. It's now at least an actual trigonometric term. What do you want to do with the sign? Make it cosecant.
Place you on conjecture.
So we have 3 times secant of x plus 1 times cosecant of x.
Yay.
Is that the right answer?
I'm happy with that answer. I have a feeling that this.
I would never know. I could have stopped at like number 2.
More simplified.
I can see this being an acceptable answer, but I'm happy with this one.
Okay.
I think that would be
What did the book put?
Numbers.
See, 1 out of a fraction is
What is that? 42?